PCP.
Okay, if I click on that, that will give us greater geometry. What it's giving us is, I mean, we could really do with a print of this, to tell the truth. I'll leave this open. There's too much information to speak out or to write down, but the bearing that we're after is there.
It's fine. We can get this
now,
later.
what we want to do is the equivalent now for the second bearing. Oh, this will actually work for both bearings, won't it? Because we exceed the load ratings are very similar for both bearings.
Yeah, but
what we may have now is an issue with the geometry. Can we dig out? We have to see where our bearings go, because our bearings are not at the end of the shafts, which means that one of the bearings is going to have to be bigger than the required diameter for one of the pulleys, because it's between the pulleys.
Yes.
Okay, can we find where our layout that we selected was? How are we laying it out? That's the one. So on page 18 we have our layout becomes okay.
So
what we have to do now is now we've selected our bearings that will meet our loads. We didn't actually specify any factors on the bearings in terms of losses or anything of that nature. Is that, if you just go through the design guide from the bearing catalogue, just to see, do they recommend? It's taking its time. Principles of bearing selection and application. Do we require any? We have no notions of lubrication at the moment or anything of that nature. Okay. Selection of bearing type. Okay. Okay, I'm going to do a survey. Loads, misalignment, precision, speed, quiet range, stiffness, axial displacement. Most displacements of interest. Shafts on a rotating machine components are generally supported by a locating and a non-locating bearing. See sections, bearing arrangements. Okay, so we don't want both of them to. Okay, so we need one of them.
Because we need to waste.
Okay, we probably want one of them to be a rolled bearing. Now, it's my contention that purely through looking at the geometry of it, that because we have our lower loaded bearing at point A is between the motor and the pulley. If I remember correctly, bearing B is slightly higher loaded. What we should have is we should have to roll up the ball bearing at A, because ball bearings take slightly lower loads. And we can make that have a larger geometry, because it has to be larger, because we still have to have the sufficient shaft diameter to cater for the stress in the shaft in terms of the bending stress and the torsional stress. Okay?
Yeah.
So we want that to be larger.
So
we actually may need to start putting numbers down to things. Okay?
So
what we have to do, we have essentially the bearings, we just need to be able to maintain the static and dynamic loads, but we may need to over specify them, because it's actually the shaft bending which may be the problem.
Yes.
It's a long shaft.
Yeah, we can.
Transmitting quite a bit of power.
Yeah, we can have a quick look this one and just like this.
Because we can look, we understand what the dynamic. We can look these up very quickly.
Yes.
Of course, we can re-choose bearings.
Yes.
Now the ball bearings. So we're going to choose one ball bearing.
Yes.
For actual location, that's going to be the bearing, which will be a larger diameter because it's between. It'll be on the step of the shaft.
Yes. So
okay. What we're going to go is if we go to this. Product tables rolling. I mean, actually, so is it bearing units? Just this is a slight digression. We've got something for bearing units. So we've got so many pages open. I'm just going to close it all the way, all the ones. We've got the designation so we can find it. I'm just going to follow up to see if the bearings come in houses, because of course that's a further design consideration.
Yes.
But at the minute we don't actually have any housing to locate the bearings, the outer race bearings on it. Anyway, bearing units, plumber block units, I think that's what we want. We don't want grub screws. Eccentric locking collar, that would be fine.
C is 20, 21.
Okay, so what we actually have is we have, if we choose, we have a Y bearing. What's the Y bearing doing here? So that goes too many windows. So bearing units, okay. Flanged. So we have Y bearings. So what is a sensitive question? What is a Y bearing? They're insert bearings. Okay, SKFY bearings are basically sealed deep groove ball bearings in the 62 and 63 series with a convex sphere outer surface. These bearings are manufactured in a number of different series and sizes and are available with both inner ring or an inner ring that is extended on both. Okay, standard inner ring or an inner ring that is extended on one of both sides. The various bearing series differ when the bearings are located onto the shaft. The most common method used anywhere in the following: grub, screw locking. No, I don't like that. Interference fit, I think, would be fine. Eccentric collar locking, adapter sleeve locking. What does adapter sleeve locking do? Okay, looks like it's simply tapped. There's a thread.
Yes.
Okay. But interference fit, I think, would be fine.
Yes.
For this. Now, the benefit of choosing these is that we haven't got to worry ourselves afterwards with choosing the appropriate housing for the bearing. And this provides the fact that it's got a convex sphered outer surface, I suspect means it deals with concentricity problems quite well, or a misalignment of the housings relative to the shaft. I'm not of course sure what that does to the load ratings, but I think this is what we want. Unfortunately, these are all deep groove ball bearings, and what we want to know is that does this housing provide any axial, any allowance for expansion? Because as this thing runs, if it starts to get warm, the shaft will expand.
Yes.
The reason that they recommended you have one fixed and one free bearing is that if you have them both fixed, you actually start to build up quite a lot of axial load as it expands.
Yes.
So you need one just to have some freedom to move. Now, we could choose one of these. I suspect we might want to choose one of these for the shaft at the, perhaps the ball, and make it large. We can choose a large one because that deals with the actual location problem and the housing problem. What we do at the roller bearing, I'm not so sure. Just because if we can actually choose something which has, I mean, we can just choose a separate housing for that. SAF series with spherical roller bearings on adapter sleeves. Okay, what does that mean? Basic load rating dynamic. These seem to be quite large. They deal with quite large shafts, 86 kilonewtons. What does it actually look like? Okay, so this is what this looks like. We have roller bearings. It looks like they may actually have, they've got labyrinth seals. Now, do you think this is something that we want?
I think it's bigger.
It's very large. I mean, the dynamic load rating is 86 kilonewtons, so we only need 20 at the moment. So it's 4 times what we're after. Okay. Let's go back to the product tables.